Natural physics is a concept I developed that explains in down-to-earth scenarios how the principles of physics could have come about from observing nature. Each episode begins with a scenario followed by an example to illustrate the application of these principles in futuristic research at the frontiers of science, such as my astrophysics research, and then concludes with an exploration of how these same principles could have very well been used by ancient cultures and civilizations. Mathematics is naturally encountered and incorporated as the exciting and fun tool of science that it is. Science is the window into our amazing world of nature, and mathematics is the tool to open that window. Natural physics encompasses current, futuristic, and ancient physics, and ties them together by the principles of physics that are common threads running throughout each. Greetings. I'm Leroy Larry, and welcome to our Natural Physics Variety Show, live from Costa Rica. Today, our guest is author August Wohlgemuth, here to talk about his new book. Mr. Wohlgemuth, is it okay if I call you August? Okay, all right. Okay, so August, my first question, August, can you tell us how did you come up with the title Northern Constellation?
Google, not Google, GT chat box.
Okay. And what does that mean, your title, Northern Constellation? What does that title mean, August?
Because it's on the northern part of the, it's all Canadian astronauts, so, it's the Northern Constellation, so.
So you're north.
Yeah.
Okay. Now, Canada's mission to Titan. You already kind of said why you got Canada's, but could you tell us a little bit more about that part of your title, Canada's mission to Titan? Where did you come up with that from?
Kind of just the mission.
Uh-huh. All Canadian astronauts, right?
Yep.
Now, I'm curious about something, August. You're very aware of the United States space organization, NASA, correct?
Yeah.
So, when you specify that is Canada's mission to Titan, you're kind of saying that Canada has its thing going on too, huh? Just like NASA,
Yeah.
Canada is out there doing it too, right?
Mm-hmm.
Right on. Now, how did you come to know about Canada's participation in the space program?
With Mr. Bruce.
That's what I thought. Yeah, that's what I kind of thought. Bruce, Mr. Callow, all the way into NASA and being Canadian, there is the connection. Yes, indeed. Yes, indeed. Okay, so Northern Constellation, Canada's mission to Titan. I think it's a very catchy title. It's very intriguing. It gets your interest. Now, my next question, August, why did you select Titan for your mission? Could you tell us about that?
Me and Mr. Bruce Callow were watching a video of it's actually more uh colonizational to live on Titan instead of Mars.
And I tell you
Because
what,
of the atmosphere.
Yeah. You know what, August? I was curious when I read your book of why you picked Titan. And I, on the internet again, world's largest library at your fingertips. uh, I looked it up and I was not aware that Titan has a lot of properties that makes it a very suitable place to try to settle for earthlings to try to settle. I didn't know that. I mean, yeah, you always hear about Mars, the moon, of course, but I come to find out that Titan has an atmosphere, a lot of which is methane, which is can deal with that, right? And the gravity, and it has a solid surface as far as we know. So I did not know why you picked Titan, but now I know. Of all the planets and moons within our solar system, evidently Titan is at the top of the list as far as being possible to be settled upon. I did not know that, August. Thank you. That's so cool, right? And you know what's even more cool? The fact that Titan is the largest moon of Saturn, which, as far as we know, Saturn is like Jupiter. It's a big ball of hot, seriously hot gas, tremendous pressures, but no solid surface. So it's amazing that even though Saturn does not have a ground, a solid ground to establish a settlement on, Titan does. Titan has a solid surface. That's so interesting. That is very interesting. Okay. All right. I wanted to ask you about the title and why you picked Titan. Okay. Now, going further, August, that's a cool picture, by the way. That is
It's AI.
what's that?
It's AI.
Is it okay? August, AI, artificial intelligence. Now, Bruce, he's shown me things that he's done with AI, cartoons and whatnot. Could you explain to me what how do you use AI to make this picture?
Uh, Mr. Bruce guy just went on the internet and found a AI picture maker, so he went on it and made all my pictures.
Okay. So that's how you did that. Because I was wondering what artists that's a beautiful picture. I mean, you imagine you're on Titan, there's the solid surface, evidently sand, like a dune, right? And you have your astronauts, male and female, and there's Saturn, the planet that Titan is orbiting around, and there's the sun in the background. That's a very, very, very cool picture. Okay, all right. I'm gonna scroll down, August. All right, I'm gonna scroll down because there are some very cool pictures in here. Okay, okay, here we go. All right. Now, this is your mission patch. Can you tell us how you designed this patch?
Uh, of course, it has to have Titan and Saturn and Titan and a rocket ship,
Yes.
and the Titan missions,
Okay.
and another thing I did is you. There is the Big Dipper right there.
Okay. That's the Big Dipper. Major,
Yeah,
major constellation. Okay. I see it.
and then let me just find Cassiopeia. I did.
Cassiopeia. Okie dokie. And that
Aha! There it
rhymes.
is.
Where's Cassiopeia? Cassiopeia? Okay, that's Cassiopeia.
It's upside down.
That's okay. Cassiopeia. All right. Very well known constellation. So you have the Big Dipper and you have Cassiopeia. Okay.
And
Okay.
those are only able to see on the northern hemisphere,
Right on. That's right. Because you have
I
the no.
think.
No, you're correct. You have the northern hemisphere and you have the southern hemisphere, and there's certain constellations that appear are visible in the northern hemisphere, and there's certain constellations that are visible in the southern hemisphere. Yes, August, that's correct. Yes. Excellent. Okay. Now, I see Saturn.
Whoops.
I see Saturn there. I see your spaceship, your rocket. And I'm assuming that that other circular planetary body, would that be Titan?
Yeah.
I said
Right
planetary
here?
body, moon body. Yeah, Titan. Okay.
Yeah, that's
Okay.
it.
So what you have is you have your rocket traveling from Earth. It's using the Big Dipper and Cassiopeia as navigational guidelines to kind of help keep track of where it's at on its way to Titan. And then you have Titan and you have Saturn, and you have Titan represented as a moon orbiting Saturn. Most excellent. Most excellent. Okay. Now I see at the bottom of your patch, you have CSA and ASC. Could you tell us what that stands for, August, please?
CSA is Canadian Space Agency, and then the one next to it is Canadian Space Agency in French, and I have no idea how to say it.
In French. All right. Excellent. Excellent, August. Very cool. Very cool mission patch. Yes. Colorful. Very cool. All right. We're going to scroll down a little bit more here. All right. We'll scroll down a little bit more. All right. Okay. Okay, hold up. I want to go back. August, I have to tell you, I enjoyed reading your book so much. And okay, this cat.
That's
AI,
AI.
AI, right? Okay, AI.
Okay, that's
Oh,
better.
okay. Now, hmm, I wonder where you got the name Hamlet from for your. I wonder where that came from.
My cat.
Right on. Okay. Now, Hamlet is a robotic cat that has been engineered to carry heavy objects. And by the way, August, I think it is an excellent mission plan where you have robots such as Hamlet arrive at Titan a whole year before the human astronauts get there. I mean, that's a great plan. NASA should, as NASA plans its missions to the moon and Mars, might want to think about that. Robots that go there ahead of time, get everything ready, all smooth and organized and put together so that when the astronauts get there, they can do what they're supposed to do. Because, hey, there's some things that robots cannot do that humans can do, right? I mean,
Yeah.
yeah, exactly. So, but for
And
the
Hamlet's tail works as one of the crane hooks, so it grabs onto the uh, plates, and then the little tiny mouse of Pete's, he wraps his tail around the hook to get it onto the rope to pull it up, and then Hamlet swings it over to Peanut.
oh, we're gonna get to Pete. We are seriously gonna get to Pete. Okay, so Hamlet. Now, Hamlet is made out of metal, correct? Is there a special type of metal that Hamlet is made out of in order for Hamlet to be able to function okay in outer space?
1 second, I gotta get my sheet of metals.
Okay.
Okay, I don't have it right this second, but
That's
it's
okay.
the same metal that the aircraft and submarine is made out of.
That makes a lot of sense. That is excellent logic. Yes. Okay. So the metal that is going to be able to withstand atmospheric pressures and also to withstand the pressures below the ocean on Titan, the methane ocean, that's the suitable metal to use. Excellent, excellent, excellent strategy. Okay, now back to your statement about the tail. Okay, the tail of Hamlet is like a hoist where it can go down. Actually, it's like a crane, like you said.
Yeah.
It can go down, pick up something, and then hoist it up onto its back. Correct?
Not on his back, on Peanut's back.
Okay, so we're gonna have to get the peanut. Okay, so Hamlet's the crane then. Hamlet does all the lifting
Yeah.
and moving heavy objects around to place them onto Peanut, which we'll get to Peanut too. Okay, now I noticed that Hamlet's eyes, I noticed that they look like they are some type of sensors. Now, can Hamlet see as a regular cat, or does Hamlet use, remember? Remember the electromagnetic spectrum, right? You got different ranges of light. We have the
He sees
optical.
just like a regular cat.
Okay, so he sees
But
in the
he can, it's one of those, it's like one of those, he can see like a regular cat, but sometimes, CSA is able to turn on this special filter that it, senses the heat, like the, heat cameras, and then he goes
Okay.
to the heat area.
Okay, so Hamlet can see in the optical range, which is again violet, blue, green, orange, yellow, and red. And he can also see in the infrared, he can see heat. So basically, August, Hamlet can see in the same ranges of light that the Hubble Space Telescope and the Webb Space Telescope can see in. The Hubble sees in the optical. The Webb, the James Webb Space Telescope, sees in the infrared, sees heat. So Hamlet can see what Hubble and the Webb Space Telescopes can see. Wow, that's serious. That is some serious ability. Okay. Now, August, I notice Hamlet has ears. Are those in any type of audio sensors? I mean, can he hear?
No, it's just for fashion.
Just for fashion. Got to keep that fashion going, right? All right. Okay, then. All right.
Actually, it's for fashion, but there's a little tiny kind of mic in it, so that it can pick up the noises on Titan when the robots are still there. But none of the other robots. Well, it's the only one with ears, but it's just for the show of a mouse. So yeah.
Okay, this is some serious engineering. Okay. Now, I notice that Hamlet has a nose. I'm going to assume, because of your description, that the ears are for fashion. The nose is for the nose, the whiskers, that's for fashion, right? To make him look like a real cat. And I'm sure Hamlet appreciated looking like a real cat and not like a robot, right? He may be AI, but hey, Hamlet wants to look like a real cat. Okay. All right. Now, I noticed this joint right here. Now, that looks like some kind of a rotor, something that will enable Hamlet for his forward limbs to move. Is that correct? Okay. So these are circular motors, or they're rotaries that can rotate, that will allow him to move his front
forearms just like a cat would. And then back here, I see another rear rotor that will also allow his rear legs to function just like a normal cat. Correct?
Yeah. And also right here is another one of the joints.
Uh-huh.
So it's able to walk and also move its arm like a regular cat.
Excellent. That is some serious engineering design. That is
And
serious.
the same on the other side too.
Yeah, I can kind of see the outline of it. Okay, so we have a rotary right here on the right side. We have a rotary over here on the left side. We have a rotary here on the rear right leg and on the other side as well. And then we have these rotaries right here at the elbow joints that allow Hamlet to walk just like a cat. Okay. And what
And
I
then
all yeah,
he's moving the stuff around. His claws actually dig into the ground so that it's like an actual crane where it has those big stabilizers and it pushes down on the ground to stabilize it.
see,
Uh,
I was gonna ask you about that, August. I noticed the claws, serious looking claws. And by the way, Balo and Dini, every now on a regular basis, we have to trim their nails because when they get on our laps, they like to grip. And let's just say I'm wearing shorts and Deanie's on my lap and his claws are digging in. And I mean, it's awesome. It's love, but it's a little painful. I mean, his claws, they yeah. So yeah, Tears and I, we definitely have to trim both. And Balo, same thing, right? I mean, no, both of their nails, they grow so quickly, and running around outside, I guess makes their nails grow even more quicker. But yeah, I saw that. And you know what? By the way, August, now the claws are digging down into the surface of this floor. And there's another force that we haven't talked about called friction. And just like with the force of gravity and the force that you exert, you and Juliet exerted in those videos that we watched, there is a mathematical equation in physics that describes that frictional force, the force that keeps Hamlet from sliding when he goes to pick up a heavy load, right? And put it on Peanut. The force of friction, that's a force. It's just like the other forces. It it it's a it's a phenomena that we observe in nature, and just like all the other equations, you had physicists that did experiments to try to come up with an equation that describes friction. And we'll get to that later down the line, but just know that there is an equation, a physics equation that uses mathematics to describe friction. Okay, so all right, continuing on with Hamlet. I have a question, August. Is he able to swivel his head back and forth and up and down?
he's able to look like this.
Okay. Okay. So in his neck, there is some type of a motor, just like you have for his shoulders
Not
and his,
really a motor.
not a
It's
motor.
you know our spinal cord.
Yes.
It's kind of like that, but it has special there is a little tiny motor in each of them, and it pulls like a hard elastic, so it bends its spine, and it comes back up, and then it bends it the other way, and then there is some going this way, and some going this way. So it can
Right.
go like this and like this and like this and like this.
Like this and like this and like that and like this. Hey, like this and like that and like this. And hey, August, that is some serious engineering. Like the spinal cord.
Yeah.
You're using engineering to simulate the natural motion of our spinal cords as human beings. That is some serious engineering. That is some
And the
now,
tail is the same way too.
as you were describing how the engineering involved with Hamlet's neck was simulating the human neck and the spinal cord, I was looking at the tail and I thought about how supple the tail is. And I thought that's kind of similar. So I wonder if the same engineering is used with the construction of the tail to simulate the bone structure in the tail of a cat or a dog or any other four-legged person that has a tail and enable that flexibility. So, okay, you answered my question. Okay, and then at the end of Hamlet's tail, so you have as the neck, you have the engineering that simulates the bone structure to allow the flexibility. And then at the end, you have a grappler, something that can grab.
Uh, it's not really a grappler.
Okay.
That was just the like AI version of like the fur coming off the tail, but it's actually supposed to be a hook
Okay.
instead of a grappler.
Some
It's
grab.
actually
Okay.
yeah,
Okay.
hook to
Okay.
lift it up.
All right. Point is, it's mechanical, whereas the tail, like the neck, is more. I don't know if that'd be called bioengineering or engineering that tries to simulate organic living organisms and how they operate. But okay, okay, all right, okay,
Actually, to tell you the truth, it actually is kind of a grappling hook. Like it's actually supposed to grab the rope, then pull it up
okay,
instead of hook the rope, then pull it up. It's actually to grab the rope, then pull it up.
all right, all right.
Pete's
Excellent,
tail is the same way too.
excellent, excellent. Okay, okay. Now, August, back to our physics about weight is equal to mass times gravity. Okay, now, here on Earth, Hamlet, in the objects that he's lifting, they are being pulled down by gravity, right? 9.81 meters per second squared. So, for example, if you have an object that's mass is, let's say, 5 kilograms, then Hamlet is going, the weight of that object then is going to be its mass times gravity, which would be 5 kilograms times 9.81 meters per second squared. That's going to be its weight. So Hamlet, with his tail and his hook, is going to have to be able to apply a force to that object that is more than its weight in order for Hamlet to be able to lift it, right?
Yeah. And
And on top of that, August, Hamlet is going to have to be able to carry that weight over to Peanut, right?
don't say Peanut too loud. She might come over.
Oh, Peanut might come over?
yeah.
Really? Seriously? How is that? How's Peanut going to come over?
My dog's name is Peanut.
Oh, I didn't know you had a dog. What kind of dog is Peanut?
German Shepherd and English Lab mixed. So she's a big dog.
It's amazing to me how animals have their own personalities. Don't you agree?
Yeah.
They do, just like we do. Just like we do. And just like uh Osco, Balu, and Dini have their personalities, and they're different species, right? Feline for cats and canine for dogs, but they still have their own personalities, just like we do. There is absolutely no difference. No difference, right? Do they hang out together? Peanut and Hamlet?
Sometimes.
Sometimes. They get along, right? Though they don't fight or
Yeah.
nothing, huh?
Sometimes they get along and sometimes they don't. Like when Peta is chewing on her bone, Hamlet walks over and she growls at him because she thinks he's going to steal her bone. And my dad says, "It's like the size of his face. How do you think he's going to carry the bone away?"
Oh, that's so cool. That's so cool, August. Oh, Hamlet. What's up, Hamlet? Hey, Hamlet. Hey, Juliet. Hi. All right, Juliet. Okay. All right. Hey, Hamlet. Hey, Juliet. Excellent.
Yeah, he's a backup.
Hey. Okay. All right. Excellent. Okay. You explained very, very coolly his optical sensors, his eyes, that he can see in the optical range, red, orange, yellow, green, blue, and violet. And he can also see in the infrared range, right?
Yeah.
So he can see what the Hubble Space Telescope, which sees in the optical range, and the James Webb Space Telescope, which sees in the infrared range, the heat. You said his ears are aesthetics. They are for appearances. Okay. His whiskers, the same. Now, I would like to ask you, and his nose is the same as well.
Yeah.
Does he make a sound? Does he have acoustics?
Yes, but maybe I don't have it here right now.
Uh-huh.
Maybe next class I'll have it.
Okay.
My grandpa's. I took out all of the wires. It's a big circuit board and it makes sound. So I took all of the cat sound out and then I put in something new. So I'll have to make it again.
Okay. That was one of the most coolest requirements that you had for your astronauts, is that they each take a pet. August, that's beyond excellent. Oh, wow. What an excellently planned mission. Your book contains so much logical information about how to plan a space mission and the different stages that have to be looked at. Okay, August. Now, Hamlet's oratory functions. Is Hamlet able to make a noise, make a sound, meow?
Yeah.
Okay.
But it would sound like a robot meow.
A robot meow. I wonder what that would be like. Meow.
Meow.
What'd you say?
Meow.
Yeah, I got you. And you want it to sound more like meow.
Yeah. That's
Okay.
kind of what the circuit board sounds like at my grandpa's.
Hey, Hamlet, we are going to try to make your meow accurate. Let me ask you a question, August. As your spacecraft goes by each planet, you're gonna leave Earth and you're gonna go by Mars and then Jupiter, and then you're gonna get to Saturn and Titan. What's the one force of nature that you're gonna have to take into account to get your spacecraft to Titan? What is it? What's the force of nature? What have we been talking about? What's the force that keeps you on the Earth?
Gravity.
That's right. And each planet has its gravity. Each moon of each planet has its gravity. You know what, August? When your spacecraft gets to Titan and Hamlet starts doing his thing, along all the 200 hamlets, they're going to have to be able to handle the gravitational field of Titan, right? Now, do you remember, is the gravitational field on Titan less than or greater than on the Earth?
Uh, Greater, I think, again.
Now, remember, Titan is a moon of Saturn, and Titan is not much more bigger than our moon. On our moon, is the gravity more or less than on Earth?
Less.
Less. So what do you think on Titan? Titan is a moon of Saturn. Do you think it's less or more?
Less.
There you go. Okay. So, in other words, August, when Hamlet picks up an object with its tail on Earth, the force that it has to apply when Hamlet is on Titan, it's not going to have to apply that much of a force because the gravitational force on Titan is less than on Earth. So the hard work that Hamlet would have to do on Earth to pick up these objects and transport them to Peanut, he's not going to have to work as hard on Titan to pick up those weights and transport them to Peanut. All right, August, Juliet. All right, August, I will see you next week.
Bye, Mr. Hawaii.
Okie dokie. Bye-bye. All right. Okay.
I had fun talking about my book today.
And we're going to continue because your book needs to be talked about. It's a great book, August.
Thank you.
You're welcome. All right. Tune in, everybody. Next week, same fat time, same fat channel, as we continue talking about the most excellent book, Northern Constellation by August Woolgamuth. All right. Bye, August. Bye, August. Okay. All right.